So there's my diagram. Okay, once I've got the diagram drawn, so we got the initial part and then the final part, I like to label them. So this is position 1, this is position 2. So the continuity equation is this: density at 1 times area at 1, velocity at 1, equals density at 2, area at 2, velocity at 2. So the density at 1 and the density at 2 are going to be the same unless I tell you something different. Okay? I did not say anything about it, so we're assuming they're going to stay the same, so they'll cancel out. The area. It's the area of an artery, which is circular, roughly. So that's going to be pi r squared for the area. And I'm not going to convert the centimeters here, and here's why. Notice that all my units are centimeters. This is centimeters, this is centimeters, this is centimeters. This one is meters, but it's density, and I cancel out the density. So everything's in centimeters, so I'm going to leave it all in centimeters. So it's pi r squared times the velocity equals pi r squared times the velocity. I also notice that pi is on both sides, so I'm going to cancel out pi. So 1.2 squared times 40 is 57.6 equals 0.8 squared. Should be 0.64. Yep. Okay, divide both sides by 0.64. And you get 57.6 divided by 0.64, 90. Yep, centimeters per second. Now, if these weren't all in centimeters, you would have to convert. If not everything was in centimeters, you would have to convert. But because everything's in centimeters, I didn't have to do any conversions here. Let's just double check and make sure this answer makes sense. So we always know that where the pressure is lower, the velocity is higher. It's going to have to go faster because it's compressed more, and that's going to spread it out because, remember, the amount of stuff has to be the same. So if lots of stuff makes it through slowly, then we have to have, at a higher speed, less stuff making it through. And that's going to cause it to go faster to keep that flow rate the same. So the mass rate stays the same, the velocity will change. So this makes sense, so we're in good shape. Any questions for me on that one? Okay, take a look at your review guide. Go to the back page. I want you to do 22. If you need paper to show work on, because I do want you to show work, you're going to have to on the test. If you don't have enough room on there, but you might be able to do it at the bottom. But if you don't have enough room, come grab a scrap sheet of paper from me. I got some by the hand sanitizer. I want you to try 22. Standard garden hose has a radius of 2.5 centimeters, allows water to flow through at a rate of 0.2 meters per second. The water ultimately passes through a nozzle on pressure washer, has a radius of 2 millimeters. What's the speed of the water as it exits? You need the practice 5 also. Do you not approve of this picture, Sam?
It's a picture.
You need to go to 2D art, bro.
I
You need to go to 2D art. Right. You need to learn how to draw your physics diagrams.
That should be a true representation of the flag.
All right, try 22 on the review. Try 22. And I've got the answers if you want to check your work once you got it.
What's the millimeter?
0.02.
1,000, so divide by 1,000.
Divide by 1,000.
And then you'll be proud of me. I already got the answer.
1/500.
It's already together. Yeah. I said to myself, I'm going to get this done now so I don't have to scramble at the last minute. When you get done with 22, you can keep going. But 22 is the one I want to focus on. Give you some time on. If you need help, ask. If you need help, just ask. Millimeters into meters. Centimeters would be 0.0. Yeah, it's centimeters is divided by 100. Millimeters is divided by 1,000. So it's just this equation. Yeah, 20. So try setting it up if you're having trouble setting it. But it's that I can't tell you much more than what it is.
It comes out at 31,000 miles meters per second.
So one is the starting. Two is the end. So like it says, well, where do we get a 5? That'll go with the area.
But you cross that out, you go, that's where they can't write it.
Yeah.
So you take 0.5 squared times 0.
You should be 8. I try not to do too much conversions, but this unit requires a lot more. Like, in order to make it, no, you can. I have faith in your ability to convert centimeters to meters. Can we not do it? Just millimeters is just that's a no-go.
Yeah. You got it. I got 600.
Alright, what? You can't remember that millimeters is 1,000 and centimeters.
I divided this.
It's just too much. That whole extra zero.
I'd rather have that.
No.
If you want to check your answer, the answer you should be getting is 31.25. 31.25. Okay. Let's jump back to practice 5. If you're still not done with 22, you can always come back to it. A lot of you are getting close or finished. So let's jump back to practice 5. There's one more I want to do. There's one more I want to do, and that's number 4. So this is Pascal's principle. Yep, pin pout. Pin equals pout. Pin equals pout. All right, how much force needs to be applied to a circular hydraulic disc with a radius of 17 centimeters to lift a 78 kilogram, it's supposed to be 78 kilogram object. So lift a 78 kilogram object on a circular hydraulic disc with a radius of 48 centimeters. Okay, so the equation for this one